Welcome everyone to our special segment dedicated entirely to the fascinating world of inorganic chemistry. This is our first technical episode in English, and without further ado, let's get to the essential branch of chemistry with a focus on inorganic chemistry with a fantastic guest. Welcome, Matty, and thank you for joining us.
Hi, Ira. Thanks for having me.
Could you start by explaining how inorganic chemistry differs from chemistry as a whole and what its core focus is?
Inorganic chemistry mostly focuses on the compounds that have a heavy metal, and it's different from organic chemistry, which is described as studying the compounds that only have a specific atoms such as carbon and hydrogen and oxygen. But in inorganic chemistry, there are a variety of different metals and heavy metals involved in the chemistry of those molecules, and that's how it's different from organic chemistry.
What your PhD research was for our audience? What was the essence of your study?
Sure. I worked on an enzyme called nitrogenase during my PhD, which is basically a little protein that can convert nitrogen in its gas form to ammonia, which is a great source of nitrogen, and it's used as fertilizer. So this enzyme can be found in some specific bacteria that can live in the roots of some specific plants, such as legumes, and work as a free fertilizer for the plant. And I worked on that enzyme.
What is left there in your topic that someone can pick up to build upon your research? What aspects of this topic remain unexplored or offer opportunities for further study?
Sure. Nitrogenous field is considered relatively new. There is a lot that has to be studied and figured out about this enzyme. For example, it is not completely understood how this enzyme works and the mechanistic insights that are completely uh, not unknown, but there are parts that we are still trying to figure out. There are some parts on biosynthesis of some cofactors involved in this enzyme that are still completely unknown. So that's room for research and growth in that area. And also, there is a lot of interest in applications of this enzyme and how we can improve the performance of the enzyme and how we can get it to an industrial scale for like agricultural applications.
For our viewers dreaming of graduate studies in United States, especially in organic chemistry, could you provide insights on selecting the right program? Do you have any unique application tips or golden advice for them?
First of all, find out what is your research interest, and based on that, try to narrow down the programs and the faculty members that offer that kind of research. And from there, you can see which programs you could be a match for, and you do have better chances depending on your application. So, one great thing that you can work on that increases your chances of getting admitted to the programs is getting a good score on your subject jury, and also getting a good speaking score on your TOEFL exam, because most of the PhD students in chemistry serve as a teaching assistants during their first year. So you need to prove that you can teach undergraduate students in your classes, and a measure for that is your TOEFL score.
Let's discuss hunting opportunities in inorganic chemistry. Insights beyond the United States would be a bonus. So let's start with academic venues. What are the top 5 scientific journals, conferences, and networking events in your field?
So the most prominent journal is the Journal of the American Chemical Society, known as JACS. It's very prestigious. It's not only for inorganic chemistry, it covers a wide variety. It also has different subdivisions for different areas of research. There is Angewandte, chemical reviews is very decent, nature chemistry, and depending on what area of inorganic chemistry or chemistry in general you work in, there are different journals that you can get published in that are very prestigious. They publish very current and pioneering research material. For the venues, same story. American Chemical Society has great meetings. They have national meetings, they have regional meetings. I suggest if you are a graduate student or you are trying to get into a program, attend one of those national meetings. There are a lot of people from different programs attending those, so you can build your connections, figure out would you be a good fit in a specific lab, because not only you can talk to the advisor, to the PI, but also there are students from that specific lab presenting their research or having a talk or presenting their poster, so you can directly get connected to the people who are basically on the same boat as you are, just like maybe a year or two ahead of you. So that could be really helpful.
And could you introduce some key resources, such as mailing lists or platforms that serve as gateways to positions and research opportunities in this field?
Well, I do know that the American Chemical Society, ACS, has a mailing list, but I'm not sure that whether it's available to public. But you could check their website to see if they have one that is public, or is it available to the non-members, or you do have to be a member there. There's also Royal Society of of Chemistry. That's also another one, but unfortunately, same story. I'm not 100% sure, so you might want to look into it.
What does the future hold for someone choosing this field in terms of job prospects and roles?
Well, there are different areas in specifically inorganic chemistry and bioinorganic chemistry that you could follow and build your career path depending on what you're interested in. So you could be involved in pharmaceutical industry as I am right now, during like work on drug discovery, development, formulation, and a lot of different areas in biotechnology. You can also be involved in environmental sciences, anything related to the environmental monitoring, sustainable material development, renewable energy, that also falls under inorganic chemistry, or being involved in green chemistry initiative. You could work on material science related stuff like electronics, coating materials, sensors, or batteries, or biomaterials. These all fall under the material science and inorganic, bioinorganic chemistry. Um, Also, you could be involved in data science and computational chemistry, which is very exciting because you don't have to be in the lab, so you could work remotely. That's a plus. You could work in chemoinformatics. You could work as a data analyst for different areas of research. You could work on some sort of computer-aided drug design or predictive modeling or virtual screening and that sort of thing. And also there are a lot of room for interdisciplinary collaborations to work with different disciplines like biology, physics, engineering, computer science, and medicine.
Right now, you're after PhD, so you're now in the industry. How do you describe your daily, day-to-day routine?
Well, as a scientist in the pharmaceutical industry, I mostly work on the drugs that have been already developed, so they're past the R&D stage. So what I do mostly is work on studying the stability of certain drugs, different aspects of them, running specific tests that are approved by FDA. So these different therapeutic agents and drugs can pass their FDA approving phase. So that's my kind of day-to-day job. But there are different tests, different, drugs, depending on what project, what program I'm working on. I might be doing something different every day. So that's what I like about it most. So I'm not stuck on doing one thing over and over again. It's just I'm doing multiple things over and over again.
And may I add, what are your hobbies to maintain this work and life balance?
As hobbies, I would say I like cooking, baking, and spending time with my cat. I do watch a lot of TV shows, a lot. You name it, I've probably watched it. I have watched some of them like, I don't know, a million times. I do have every dialogue from memory, I can tell you. So also, the other great thing that the past 2 3 years that this habit that I have developed is listening to the podcast when I'm working in the lab. So I put on my earbuds and listen to different podcasts. So
As we start to wrap up this segment, is there anything additional you'd like to share with our viewers who are keenly interested in this field?
I would say, first of all, figure out what you want to do. As I mentioned, there are a lot of different research areas that you could work on. So figure out what you want to do after your graduate studies. If you want to work in a certain industry, so you want to find out something related, so that could help you finding a job in that certain like area. If you're not 100% sure, I would go with something that it's more like wide, so it can provide you a good overview of the field, and then once you have an overview, you can find out what area you're more interested in, and you can just narrow it and take it from there.
Matty, thank you for such an engaging conversation. Your insights and experience are invaluable to anyone interested in this dynamic world of inorganic chemistry. To everyone, thank you for joining us. Please share this episode with your friends and other like minded people, and please subscribe to stay tuned for the next episodes on other topics. See you later, and goodbye.